Hey, welcome. Ever just stop and look at the stuff around you and wonder, is any of this actually pure? Well, in this explainer, we're going to put on our scientist goggles and take a much closer look at the everyday matter that surrounds us to find out what's really going on.
So picture this. You're at the grocery store. You grab a carton of milk, maybe some orange juice, and right there on the label it says 100% pure. And to us that just means, nothing weird has been added. But if you were to ask a scientist if that milk is pure, they would give you a very, very different answer. And here's the reason why. It turns out the word pure has two totally different meanings. In our everyday world, it means unadulterated. But in the world of science, pure has a much, much stricter definition. A substance is only considered pure if it's made up of one single type of particle. That's it. Every single particle has to be chemically identical. So if milk isn't scientifically pure, because it's got water and fats and proteins and all sorts of things in it, then what is it? Well, scientists have a name for it. It's a mixture. And the crazy thing is, most of the stuff we deal with every single day, from the air we're breathing right now to the ground under our feet, is a mixture.
All right, so once we know something's a mixture, we can start sorting it out. And the first, most obvious way to do that is just by, looking at it. Does it look all smooth and the same throughout, or is it kinda chunky?
So first up, we have the smooth ones. If you look at a mixture and you just can't see the different parts, it's what we call a homogeneous mixture. A great example is salt dissolved in water. Once you stir it up, it just looks like water, right? Same thing goes for the air we breathe. It's all blended together seamlessly.
But on the other hand, if you can see all the different bits and pieces, you've got yourself a heterogeneous mixture. The classic example is oil and water. They just refuse to mix, and you can clearly see those separate layers. A handful of dirt, or a mix of salt and little iron filings. Perfect examples. You can literally point out the different components.
Okay, so we can sort mixtures by whether they look uniform or not. That's pretty straightforward. But here's where it gets really interesting. Even among those smooth, uniform-looking mixtures, there are some major differences that are totally hidden from our eyes. So let's take a deeper look.
It really all comes down to the size of the particles floating around inside. Particles that are way too small for us to see. So you've got solutions where the particles are so tiny they dissolve and they're not going anywhere. Then you have suspensions with big particles that'll eventually just sink to the bottom. But right there in the middle, you have this really fascinating category called colloids.
So this brings up a really important question. Both solutions and colloids can look perfectly uniform, right? The particles in both are way too small for us to see. So how in the world are we supposed to tell the difference between them? Well, the answer is this brilliant little trick that involves a beam of light. It's called the Tyndall effect. And it turns out that those medium-sized particles in a colloid, while they might be invisible to us, are just big enough to get in the way of light and scatter it all over the place.
And this just shows the difference so perfectly. If you shine a flashlight through a simple solution like salt water, the light just goes straight through. You can't see the beam's path inside the glass at all. But if you shine that same light through a colloid, like our friend, milk, those particles scatter the light, and bam! The path of the beam is suddenly clearly visible. It's an incredible way to see something that's supposed to be invisible. Okay, so we've spent all this time figuring out how to identify all these different kinds of mixtures. But that kind of begs the original question, right? If all this stuff isn't pure, then what is? Well, let's finally meet the true building blocks of all matter. When you get right down to it, scientifically speaking, the whole world of pure substances is actually pretty simple. It really just boils down to two fundamental categories: elements and compounds. Everything else is just a mix of these two. So first up, we've got elements. Think of these as the ultimate basic forms of matter. An element is a substance that you simply cannot break down into anything simpler using a chemical reaction. We're talking about things on the periodic table, like pure iron, the oxygen we breathe, or a solid bar of gold.
And then we have compounds. This is what you get when two or more of those elements chemically react and actually bond together. Now, the key words here are chemically combined and fixed proportion. Take water, for instance. It is always two hydrogen atoms bonded to one oxygen atom. Always. That's what makes it water.
And this table really gets to the heart of the difference. Think about it like this. If you just mix iron filings and sulfur powder together, you can still pull the iron right out with a magnet. It's a mixture. But if you heat that mixture up, they chemically combine and form a totally new substance, a compound called iron sulfide. This new stuff isn't magnetic and it has completely different properties. You can't separate it with a magnet anymore. That's the power of a real chemical change. So wow, we have covered a ton of ground here. But the cool thing is you now have a brand new scientific lens for looking at the world. You can literally start classifying everything around you as either a mixture or a pure substance.
So, here's the takeaway, your mental checklist. To figure out what anything is, first, ask yourself, is it made of just one kind of particle or many? If it's just one type, boom, it's a pure substance. If it's many types, it's a mixture. And if it's a mixture, you just ask one more question. Does it look uniform? If yes, it's homogeneous. If no, it's heterogeneous. It's as simple as that.
And that brings us to the end. But I'm going to leave you with a final challenge. Just take a second and look around the room you're in right now. The air you're breathing, the water in your glass, the actual screen you're watching this on. With your new scientific lens, how many mixtures can you spot? You might be shocked to realize they are literally everywhere. Thanks for watching.